So now that you've been introduced to the concept of the managed blocker mechanism in the common fork join pool, let's go into more detail about the managed blocker interface so you can see what it's actually intended to do. And you'll see that one of the benefits of using managed blocker, a couple of the benefits of using managed blocker, is to help avoid starvation and to help improve performance. The Java ForkJoin framework is largely designed for tasks that run to completion without blocking. What that means is it's intended for use primarily with computation or CPU-bound or core-bound tasks. The managed blocker, however, is used or is intended for use for cases where you need more worker threads to ensure the liveness and responsiveness for blocking operations. So the key focus there is blocking stuff. Things that block are not really run to completion tasks. And interestingly enough, if you read the ForkJoin pool documentation, it kind of indicates it's really intended for use with non-blocking or run to completion style computations. So it's a bit of a little known fact that you can use the managed blocker to avoid the limitations with ForkJoin pool out of the box. It's kind of a mystery. Most people don't know what we're about to cover, so it's important to be aware of this. And as I mentioned before, it's also very important to be aware of this in the context of your next programming assignment. And what managed blocker does, just to reiterate what we talked about before, is it automatically and temporarily increases the common fork join pool size. And what that means is that the common fork join pool can reclaim threads during periods of non-use and then reinstate them later if they're needed again. So you can think of it as kind of this, like a Grim Reaper kind of thing that will shut things down, but then it also allows them to be rebirthed in a sort of samsara-like way. And what it also does is it tries to create or activate threads to ensure the appropriate target level of parallelism. You can set what that target level is, and it tries to keep it within that bound. The managed blocker interface is really, really simple. It just defines a pair of methods. So here's the managed blocker interface, and you can see it has two methods. The first method is called isReleasable, and as you can see, it returns true or false, and its intent is to return true if there's no need to block. So if for some reason something might block, but under the circumstances it won't block, isReleasable should return true. And what that means is that in the context in which it's used, the resource you're trying to obtain, maybe it's a lock, maybe it's a message, can be obtained or acquired without having to block anything. And that's good because that tells the framework, no need to do all this extra compensating work by creating another thread. I got my resource, we can keep going. Another method is block, which may very well block the calling thread. And this is typically where the actual computation would go. And in this particular case, it's going to be waiting for something like a lock or an IO operation. So that's actually where the business logic resides in the managed blocker interface. And we'll see how that works in a second. Block returns true if no additional blocking is necessary as well. Same kind of semantics as isReleasable. So how does the ForkJoin pool itself, how's the common ForkJoin pool implementation going to apply managed blocker under the hood? Because that's really the key issue here. So if you take a look at the ForkJoin pool class, this is what you get if you look at the Java source code. You can see ForkJoin pool extends abstract executor service. So it extends the abstract executor service, which in turn implements the executor service interface. And there's a static method that's provided here that's only intended for use with the common ForkJoin pool called managedBlock. And that's the method you'll call when you want to leverage the managed blocker mechanisms that are available in the common ForkJoin pool. And what this method does, and we'll talk about it briefly in a second, this method is programmed to activate a spare thread to ensure sufficient parallelism while a calling thread is blocked. So if it's the case that the task that you're executing blocks, then this particular mechanism will activate a spare thread doing something called compensate. And you can see here what you do is you pass in your managed blocker, and we'll take a look at how you might do that. That's the code that you write, filling in the is releasable and block methods, and you provide that into the managed block method, which is a static method which works with the common fork join pool. And what this does, it goes into a loop, and basically while the blocker hasn't been released, it's going to call this internal helper method called try compensate. And I won't bother walking you through the gory details of try compensate, but basically what it does is if there aren't enough threads that are live, in other words, not blocked on I/O, it will try to create or reactivate a spare thread to compensate for blocked joiners, things trying to join, until they unblock. So basically what it's doing is it's trying to compensate for the fact that something's blocking by spawning another thread so that that thread can make some forward progress. And as you can see, there's a bunch of loops in here which do things like try to acquire the resource without blocking. If it's able to do that, we're done. Otherwise, if it's not able to do that, it calls the block method, which may very well block the thread, but that's okay because we've already set up this compensation mechanism above. So if this happens to block, that will cause the Java common fork join pool to spawn another thread and let it go and do something else while this task is blocking, waiting for whatever it's waiting for, I/O, synchronizer, message, so on. So that's the end of the quick overview of the Java ForkJoin framework's managed blocker interface. We will come back and talk about this in much more detail and look at some examples here shortly.